Okay, so for number one, it tells you to find the domain of the following graph. Remember, the domain is going to be your x values, and you're going from left to right. So if I start here from the left, my leftmost part is going to be -6. And remember that since it's the x value, that's why it's -6 instead of 0, because it's the x values. So I'm going to have -6. And then if I were to go all the way here to the right, that's +6. Notice how both of them are closed circles. So we have brackets. So that means that our domain for number one is from -6 to +6. Now, same thing here for number two. We are going to start with my leftmost value. It's going to be -6 again, not 2, because that's the y value. We don't want the y value, we want the x value. So we have -6. Notice how it's a closed circle, so we have a bracket. But notice how here at 11, we have an open circle, so that's going to give us a parentheses here for my domain. Now, for number 3, it's talking about range, and this is where things are going to get a little bit tricky. Now, remember that range is the lowest of the low and then the highest of the high. It's the y values. So here, the lowest of the low in terms of the y value is -8. So I'm going to have -8. And notice how here, again, I have a closed circle, so I have a bracket. And then my highest of the high is +6. And again, it is a closed circle, so we are fine there. So my range here is from -8 to 6. Okay, same thing here. The lowest of the low is 1. And the highest of the high is 6. Oops. Now, you might be thinking, okay, but why is 1 and why is 6 a bracket instead of parentheses? If they do not give you a open circle, then we're always going to assume that everything is a closed circle. So this is a closed circle, and this is a closed circle. Notice how here, this right here doesn't really matter, and this right here doesn't matter because it's not the lowest of the low or the highest of the high. Remember, range is the y values of the minimum, your lowest, and then your maximum, which is your highest. For number 5, I'm going to ask you to find whether it's increasing or decreasing. So in this case, we are increasing, meaning that I'm going to go up. But remember that it's in terms of my x values. So I'm increasing from 0 all the way to 7. So so 0 to 7. Whenever you talk about increasing or decreasing, it's always going to be in parentheses. So always parentheses. Now, if I told you to find out where it's decreasing, then that would be from 7 to 15. That is decreasing. Number 5, or not number 5, number 6, this is a special notation right here. This is just saying when is f of x greater than 0, aka when is f of x positive. Greater than 0 is positive, so we know that we are positive from -6 to -2. Notice how here, because it's strictly greater than 0, I'm not including -6 and I'm not including -2, because -6 is not greater than -6 and -2 is not greater than -2. But if I said when is f of x greater than or equal to 0, then I could say -6 and +2 with brackets. So remember, greater than 0 means that I am positive, I'm above the x-axis. If I said, once again, maybe it's this one. If I said when f of x negative, this is saying f of x is less than 0, aka what's before or below the x-axis. So we're below the x-axis here and here. Notice how here we start at negative infinity and then we stop at positive 1 right here. And once again, like I said, because I want a negative value, it's straight to less than 0. Since it's straight to less than 0, 1 is not less than 1 in this case. So, or 0 is not, sorry, not 1. 0 is not less than 0. So in this case, once again, we have a open circle, not open circle, a parentheses on 1. Same thing with 5 here. 0 is not less than 0. So we have union, 5 to infinity. We're reading this from left to right. So going from negative infinity here to positive 1. And then going from positive 5 to positive infinity. Going from G to H, notice how from G to H we are increasing because we're going up, and we're also positive because it's above the x-axis. So G is positive and increasing, G to H. Now H to I, we're increasing because we're going up, right? But notice how it's below the x-axis. So we know that it's going to be negative, but we're still increasing. Now, if it's positive and decreasing, that would be something like B to C, where I'm positive because I'm above the x-axis, but I'm decreasing because I'm going down. Negative and decreasing would be something like C and D, where it's below the x-axis and I'm going down. Find all intervals in which f is decreasing. So basically, when am I going down? I am going down from negative 3 all the way down to 2. Now remember, I told you guys that decreasing, increasing, always use parentheses. So then right here to here is 5 to 7. So I have 2 intervals where I am decreasing. Negative 3 to 2 and 5 to 7. Now this one says, when is f of x greater than or equal to 0? Notice how now I can include the zeros. So whenever I'm looking at anything above the x-axis, I could say negative 8 to negative 5. And then I could say 1 and 3. So it's above the x-axis. We're including 1, we're including 3. So we have negative 8 to negative 5, 1 and 3 in brackets. And then we're going to put U right here in terms of the union symbol. And then for number 12, the absolute minimum is basically the smallest value. So in this case, my smallest value here is going to be negative 7. Notice how whenever I'm talking about the absolute minimum or absolute maximum value, I'm looking at the y value, the lowest of the low in this case. Now, this does not have an absolute maximum because I could go on forever and ever and ever and ever and ever, so it does not have an absolute maximum. Now, I can have a local maximum though. A local maximum is the highest of the high, but in terms of where it's positioned or where it's at. So for example here, negative 2 would be a local maximum because it's the highest of the high before I eventually go back down. All right. Oh, there's more. 13 absolute maximum. So in this case, the highest of the high would be 4. In this case, there would not be an absolute minimum because I have arrows pointing down. But this right here is a local minimum. And this right here is also a local minimum. Notice how I have 2 local minimums. And the reason why is because negative 3 is the lowest of the low between these intervals right here. And then -5 is the lowest of the low from these intervals right here. Okay, vertex of the parabola, you should know this back in Math 1, it's just going to be the highest or the lowest point. So that would be -6, +4. It is a coordinate, so make sure that you give me a coordinate. Determine the x-intercepts. So your x-intercepts are when we have an intersection or a cross over the x-axis. That's going to be for -5 and -3. We want to find the axis of symmetry. So to find the axis of symmetry, we are going to use x is equal to -b/2a. This right here is the axis of symmetry formula. Now, in order to do that, though, we need to figure out what a and b are. Remember that it should be in the form of ax squared plus bx plus c. In this case, though, we have a. We don't have a b because b is just 0, and then we have c. So a is -1, c is 2, b is 0. We really don't care about c because the formula is -b/2a. So this is just saying -0/2 times -1. Which plot twist? It's just 0. So the axis of symmetry is x is equal to 0. Remember that the axis of symmetry is a line that essentially breaks the parabola into 2 equal parts. Now to find the vertex, you're going to use the -b/2a, and then once you do that, plug it back into the equation. So in this case, if I have x is equal to -b/2a, I have a, no b, and then I have a c. So then I have 0/2 times 1, which is just 0. Now, I'm not done because it's asking us about the vertex. So to find the vertex, I'm going to plug in 0 for x and then get my y value. Well, that's just 0 squared, 0 squared is 0, minus 7 is -7. Okay, that's definitely it in terms of the features of function video.